Hello and welcome to another session. Today, basically, we are going to see how to select the cutting tools for lathe operations. Um, this is basically an easy way to explain you the different kind of tools that you can use. Uh, from your previous knowledge and for just this subject, you should just have a little bit of knowledge about different kind of tools and cutting operations, but we will review it. And then we will see some special tools used for special operations or for the most difficult operations in order to achieve better results. Okay, so basically, on selection criteria of lathe tools, we need to select the most appropriate tool for the operation that we are going to do. Also, working in just like we need to make thousands of parts, we want, of course, a standard tool, that is what we are going to see, but also maybe a tool that can just make as much operations as we are doing on the part. If we can do the whole roughing with one tool and then the finishing with another one and then the cutting operation with another one using only three tools, that's great. Okay. If we need more tools, we need maybe to invest more money and that's just more difficult. Okay. So on this tutorial, we will see basically how to, which are the different types of tools to have you a basic knowledge when you just see a box of inserts or things like this. On the next one, we will see just the Core Plus tool guide that you can see here. Okay, so it helps you to select a cutting tool based on the operations that you're going to do. And finally, we will see also a little bit of Fusion 360 CAM operations, okay, on this next tutorial. Okay, so basically the factors that are influencing on the tool selection, the material of the workpiece, of course, the workpiece profile. Okay, it is not the same just a straight cylinder than just a chess piece, with this most difficult um, profiling and things like this. And also the type of operation that we are going to need. See if it's outside or inner, or if it's a groove, or if it's a finishing, or if it's knurling or whatever. Okay, so yeah, you have here more things. So the selection, okay, like this is better. The tool selection, we are going to see the system insert clamping, the holder size, the insert shape, the size, the tool tip, etc. Okay, so all these things that we see here are the ones that define our tool holder and our insert. Okay, and this comes from the previous things. Okay, so first of all, the system of clamping. Okay, you have different operations, and each operation requires a system of clamping. Um, Also the material, right? So here we have the system insert clamping. If we are just fixing with a lever, it is a P type. Okay, if it's with a flange, okay, this part of here is just pressing down the insert, it's C. Okay, you can just read this. Okay, with a screw and with a with a flange, with a screw. Okay, and here you have a small summary. Okay, so which are the types of inserts and things like that. One of the important things, yeah, in boring bars. Okay, boring bars are used in order to just make inner holes in, in your parts. Uh, are very tricky, okay, to select the appropriate boring bar, or just maybe you can just have one tool for just always roughing the outside of parts, but maybe for making boring operations, you need different tools because it will depend on the hole that you are going to do, okay? So the boring operation is determined by the diameter and length of the hole. Why? Because if the hole is very small and I have a big boring bar, it is not going to fit. Okay. And also if it's too long, the hole that I need to do, and my bar is shorter, I cannot do anything. So you can just buy boring bars. The normal ones are just like normal tools, a straight bar of material. Here you have like more or less a guide in order to just clamp your boring bars. Um, and that's it. Okay, that's a normal tool. But then we have the damp bars. Okay, damp bars are used in order to reduce vibrations due to the natural frequency of the boring bar. What these kind of bars are used for for just achieving better results in a shorter time. Okay, because with monoblock bars, well, sometimes you can get that kind of results, but usually you can get very good results, but you need to work slow with a small depth of cut passes and things like this. Okay, with dump bars, if we are producing lots of parts, we will achieve the same or better results going faster. Okay, so what is a dump bar? They are longer. Well, that's what they say here, but it, they are longer because you can just like work good with these kind of bars and long overhangs, okay? But it doesn't mean that they are longer because they need to be longer. They could be short also. Mm, They are longer than conventional. Inside they have a damp body, okay, this one here, which is suspended in a special fluid, okay? This explanation here is very good, but I think that a video explains it better, okay? Here you can see from ISCAR, this is um, a normal boring bar, and this one is a damped one, okay? So we are going to see this video. You can see this material, it's in here, that's a part, and it's surrounded, okay, we cannot see it, but this material is surrounded by a fluid and held by two rubber types. I don't know the type of rubber, it should be just like very well calculated. We have ISCAR anti-vibration, we have silent tools from Sandvik, we have several brands that they are doing it, and it's patent, okay? So basically this body here, what makes it damp the vibration produced when you're boring. So you can see like a representation here. And that's the natural frequency of the boring bar. The one that it's not damped, it will just continue always until you stop just machining. But the one that it's damped, it's damping the vibration. Okay, so that's it. You can just take the theory from here. So clamping methods. Okay, you have integral bar, it's a solid block, blah, blah, blah. You have a tool holder. You have a seat in V with screws. Okay, these ones are used usually with boring bars because the profile is round, yes. These are the most common or the ones that I've always seen because you can also use this kind of holder for normal tools. That's an advantage. And then cylindrical tool holders. Okay, you have this cylindrical one and you have two screws that press the boring bar to the corner. Okay, so here you have some formulas that basically what they are saying, it's the force that you are just like making in the bar when your machine, well, when the deflection, not the force, the deflection produced when you apply a force in the machining operations. Okay, and here you have a small chart where you can see the different uh, systems. Okay, so basically my tips or the ones that I've learned with the past of the years, it's that for finishing operations we are going to use always or most of the times for most of the materials that I've used, that are quite a lot, positive angles. Okay, uh, for just roughing very hard materials we are going to use negative inclination angle of the tip. Okay, then for soft materials we are going to use um, positive angle always, because it cuts the the material. Basically, what you're doing is cutting. It's not like just taking out. These ones are just like, in Spanish it's called arranque de viruta, because you are just taking out from the material. You are not just like cutting, you're just like scraping it. And then what else? Okay, so the smaller the radius, the usually the smaller the vibration. The problem that you have with the small radius is that you need to work slower. The feed it's going to be slower, because you um you know that in function of the radius you have the the surface quality that you're going to get, okay, or the roughness. So with a higher um, radius on the tip, in theory, you will have more vibrations, but you will get better results. Okay, so this is like just a sum. What else do we have? Holder size and type. Okay, so here that's a basic diagram, but you just need look here. You have the different operations. Okay, just facing, turning, just like copying, that it's like following a profile, and just here you have also the same. So in function of the operations that you are going to do, you need a different type of tool. Okay, here you have the type of tools that will work like in this type of part. Okay, and when can you just use them? These ones are the most used, okay, for external finishing. Okay, you see the insert is able to just profile most of the surface. Here you have also for grooving. Okay, that's a circular one, 90-degree one, a triangular. Okay, so this one for screw cutting in the outside. Okay, you can have also for inside. You will see it here inside, grooving inside, copying, or just here it's facing and copying, whatever you want to do. Okay, so the insert shapes, you can just like take a look on this. Basically, depending on the insert shape, you will be able to make more or less geometries or just profiling operations, but it will want, for example, a 35-degree angle. It has a higher, you can see here, accessibility, but you can just like not put too much power because it will break. It is not so hard. The structural, the insert, it's not so hard. You have here different types of insert, and when are they good or not to use. The size of the insert, okay, so this is just a normal rule. This is the maximum depth of cut that you're going to be able to do, okay, from the length of the good. Here you have a small chart also that's like practical way, okay? So if you have this radius, you can just you could use this feed rate. Rough turning roughness, okay? Here you have like the rule of thumb, or well, it's not rule of thumb, but if you apply it, you can just get more or less the theoretical um, surface roughness for finishing the same. Here you have the same, okay? So the theoretical values in function of the tooltip. So here you can just like get the equivalence, and we will see in the following videos the cutting conditions and practical tips. Okay, so for cutting conditions we will go to Coro tool, okay, and practical tips we will go see it as I've been explaining today.